So in this video we're going to show an example of resolving a definite integral using u-substitution by changing the bounds of integration. So here we have the integral from 0 to 3 of sine squared of pi over 6x times cosine of pi over 6x. And the sine function is inside of the squaring function, and what we want to notice is that if we make the u-substitution, u equals the sine of pi over 6 times x, then du dx is going to equal, by the chain rule, we'll get the derivative of the inside function, which is just pi over 6. And that'll be times the derivative of the outer function. So we're going to get pi over 6 times cosine of pi over 6 times x, which varies from what we see right here only by a constant. So I can do two things here. I can multiply both sides by dx and get du equals pi over 6 cosine pi over 6x dx, and then I could multiply both sides by the reciprocal of pi over 6, which is 6 over pi. So I would get 6 over pi du is the same as the cosine of pi over 6x dx. And once I've done this, I'm ready to make some substitutions. So I'm going to write down the original integral. I have the integral from 0 to 3 of sine squared pi over 6x cosine pi over 6x dx, and I'm going to make my substitutions, but on purpose I'm not going to write in the bounds of integration here. So we're making the substitution u equals the sine of pi over 6x. So we replace sine pi over 6x with u, we get u squared. And then from here we see that we can replace the cosine of pi over 6x dx, cosine pi over 6 dx, with 6 over pi du, and the 6 over pi is a constant, so it can be factored out in front of the integral. So I get 6 over pi du. And I've changed from variable x world to variable u world. And so I could integrate, get the result, and then substitute the sine of pi over 6x back in, and then do my evaluation from 0 to 3 using the fundamental theorem of calculus. But what I can also do is convert my bounds of integration from variable x world over to variable u world. So these bounds of integration are telling us this. They're telling us that x is running over the closed interval from 0 to 3. But u is equal to sine pi over 6x. So variable u is actually going to run over the closed interval from sine pi over 6, and then it's x. So I'd replace the x with 0, so times 0, comma, and then when x is equal to 3, we would put a 3 in for the x here. So it's going to run from sine pi over 6 times 0. When x is 0, u will be sine of pi over 6 times 0. And when x is equal to 3, u will be equal to sine of pi over 6 times 3. So sine pi over 6 times 3. So as x goes from 0 to 3, u goes from sine pi over 6 times 0 to sine pi over 6 times 3. Because of the u substitution, u equals the sine of pi over 6x. And then I could say, hey, what's this simplify to? So u is an element of, this is going to be the sine of 0, comma, and this is going to be the sine of pi over 2. 3 pi over 6 is the same as pi over 2. And then these are both special angles, so u is going to be an element of the closed interval. The sine of 0 is 0, and the sine of pi over 2 is the square root of 2 over 2 from special angles in trigonometry. So I can actually, when I do my u-substitution, I can change my bounds of integration from variable x world to variable u. As x runs from 0 to 3, where does u run? U runs from 0 to the square root of 2 over 2. And now I can integrate. So I get 6 over pi times, it's going to be u cubed, but I need to multiply by the reciprocal of the 3, so I increase the 2 to a 3, and I multiply by the reciprocal. And then I need to evaluate this from 0 to the square root of 2 over 2. And then 6 over pi times 1 over 3 is equal to 2 over pi. So I can simplify the constant terms, plug in the upper bound of integration using the first fundamental theorem of calculus. We plug in the square root of 2 over 3, and we're cubing it, minus the fundamental theorem of calculus says plug in the lower bound of integration, and then we can start simplifying things. We have 2 over pi times, we're going to get the square root of 2 cubed, which is the same as 2 times the square root of 2. And then we're going to get 3 cubed, which is 27. So we're going to get 4 times the square root of 2 over 27 pi. If we hadn't changed the bounds of integration, then we would have had to convert back to x world by replacing, after we integrated, we would need to replace the u with the sine of pi over 6x and then evaluate it over the interval from 0 to 3. So a lot of times it's going to be convenient, and sometimes it's going to be easier, in fact, to modify the bounds of integration based on the u-substitution. So you figure out, where does my original variable run? And as my variable runs from over that original closed interval, where is my new variable u from the u-substitution running to? And then put those new bounds of integration in, so you can keep things in variable u world as you evaluate the definite integral.